Welcome back, guys. So, yeah, I'm back. Last week, I tried to stream actually. So, I was streaming for like 1.5 hours. But turns out the stream got cancelled around 16 minutes. I have no idea because I was in top of my house and probably my Wi-Fi connection was not stable there. And the entire session got cancelled around 16 minutes, but I was there streaming for around 1.5 hours. Yeah, okay, so that was a bummer. But still, as I explained in the last stream, I'll be here in my hometown for next 2 months. So I'll be streaming from here and from a different setup. So I'll be trying to stream over the weekdays instead of weekends. Yeah, I'm trying to see how this new setup works and try out this. So yeah, let's just get started. So this week I guess we still trying to get the directory. Let's just type it in the chat. Directory passing, entry passing. Yeah, so this is what we'll be doing. Let me share my screen. Okay, so here last week in the stream, which is not up because of my internet, I was actually building up this template for how exactly to convert the raw bytes of a directory entry into actual directory structure. This is what I wanted to do, and I did get some idea of what exactly it needs to be there and stuff like that. So this is like a small loop I wrote. We have the let me just give you an overview. So as you know, we've been trying to write the front end for extend 4 file system, and we managed to finish a simple example of trying to open root nodes. Our simple example should be supposed to be the full access of Etsy password from fopen perspective. So when fopen gets this file name, we start by going into the slash, which is the root node. We get the um, structs. We get the inode of that. We know the inode of the root node, which is just 2. So we convert that 2 into an actual inode struct. Within that inode struct, we would actually get extents. Extents are the actual entries which is supposed to give us the physical blocks of the actual root inode. So we finished that passing. So now we have this thing called explore tree recursive, and it takes in a inode, and it gives us a block result. And this block result will actually have the count, that is how many extents, and within every extent we also have value, which would be I think it should be like this: results value, and we also have the logical block and the physical block. So we have both values. So this is what we need in general to reach any inode and the contents of the inode. And here in this case, we are reading the, so it says, let's say 2 entries. Since sequence, what times Linux parallel using Linux. what exactly do you need advice in that? Because it looks like you already have um, enough. I don't know the word. My fucking mind is not working. Have experience with STEM 32. So what's different from Linux environment? Actually, I don't understand the question actually. What does using Linux environment has to do with uh, bare metal development? I don't know if you can explain more, I'll try. Okay, so we have the results count, which is the number of extents, and within every extent, we also have the physical block. So we read the physical block, and within the physical block, we are supposed to confirm if it's a directory entry because every entry is either a directory entry or a file entry. It could be sock and stuff, but we're not gonna focus on that. In our case, we're just gonna assume that it is either a directory entry or a file entry. So we get into this and we convert this raw bytes that we took from the physical block. Okay, so if you want to get into kernel development, and if you already have a bare metal experience, uh, okay, we mm, well, if you are looking to actually get into kernel development as what is that? As a professional thing, then you should start just taking small patches from Linux kernel and start sending patches to them. That's how you can learn, and also it can help you with your CV. But if you're just gonna do it for fun, then you can start some separate projects, maybe pick up Rust and use that to develop a bare metal kernel. A simple one with some scheduling, a little bit of memory management. You can try that. But overall, you can get started. You already have bare metal experience. That's why I'm assuming where you would have already known where to start. Probably already designed some monolithic kernel kind of stuff because overall kernel is just a program that's always getting run in EL1. Also, which architecture? Is I don't know. I think you already have the good starting points. We go to okay, so you want to get into kernel. There's some article I want to. Uh, yeah, but if you actually want to get into, you mean this one? This one. Yes. Yeah, try this log. You can start writing that in what is it? Loanware.com. log slash arch 64. Yeah, start from this. I think you must have already had and have enough basic knowledge of what to do with the kernel and how to interact with physical memory. So you should be able to follow along this blog and actually write maybe a simple kernel, and then you can take on actual patches, Linux patches, and that should give you more than enough experience. But if you just want to do fun programming, then yeah, you can write something in Linux, write something in Rust. That will also help you improve your CV. Also, your EC background, right? I don't know why you want to get into um, programming. I think you guys have lots of more interesting stuff to do there. And almost all of the regulatory sectors, they don't really write code. They only generate stuff with MATLAB. So yeah, make sure you know what you actually want, because most of the places, important place, they don't really write code. You'll never have to debug code. You'll only be debugging module level stuff. Yeah. Yeah, so make sure what's your end goal, and you can decide what you want to do there. Okay, so we have the raw bytes and we need to convert it into a directory struct. And my question was whether I can just directly cast the entire raw bytes into a directory struct. That way I don't have to do any offsets. This was one idea. And I have another question, like how many directory entries are there in the physical block? Where do I find this info? You know the total size of directory entry. I don't know. I don't understand what the fuck this means. Maybe I have to think about it again. Cast the directory entry here. Increment the pointer. Okay. Let's go back to our article. And inside this, we have our directory. As the let's see. Okay, this is a directory entry, and maybe we can just write this structure. Yeah, yes, last week I had this question, like if I'm gonna take this as a structure, and if it's gonna have variable length, then how the fuck am I gonna cast it? Yeah, because it's not possible to cast variable length, right? Yes, yes, definitely. I mean, definitely you will definitely have to debug things, but in module level, like probably integrating different modules, but they don't really write any code. Mostly everything is just MATLAB, because almost everything you write, there will be some regulatory standard and they won't let you write code with hands. If your code is written by hand, probably it is already not up to some standards, so they'll just not accept it. At least this is what how it is in automotive sector, and probably in anywhere any telecommunication, because they are like safety critical, so they don't write code, they generate some, what's that, ASM, I guess. Not assembly, it's some ASM. They create modules and they pass it down to generators, and generators develop the code. So, but you'll be debugging things in the module level, so it will be good to understand what you are interacting with, but you won't write code. Maybe only if it's a startup, or maybe it's a small device, maybe in that case you might write things on your own. But yes, you can definitely learn this low level programming and it will definitely be good. Also, because you have electronics background, you can also get into the architecture level stuff. You can maybe design some small RTL for a simple ARM architecture, things like that. If you have some board, yeah, you can try a lot of stuff because you have both electronic and computer science background. Because I did my master's in microelectronic systems recently. We got to develop a simple chip, like a fine, I guess 15 nanometer chip, I guess. No, 20 nanometer chip. Yeah, I tried to develop something with less than that. I was not able to get it working because I got lots of leakage. But overall, yeah, if you have electronics background, you have different stuff. You can even go down till architecture level or even IC level, and also you can stay in kernel level, because kernel level, if you consider electronics, kernel is not really low level, it's really high level, because kernel is just interacting with instruction sets, and instruction sets are actually designed using Verilog or something like that. So yeah, if your end goal is about understanding more about the hardware, maybe you can try both architecture level programming plus a little bit of kernel, because kernel is not low level. Kernel is still high level, at least from your point of view. Only from computer science background, maybe kernel is the lowest level you can go, maybe bare metal. Yeah, but it will definitely be useful. You can definitely try things. Yeah, but if you want to stay here, always make sure you send actual patches to Linux, because that should improve your CV a lot, and it's like an actual work experience. You will be that will be valued more than your actual, even if you have some real world experience. If you land a patch in upstream kernel, it's more than valuable. Yeah. Okay, next, classic directory entry. Each default directory entry is I don't know. Fuck. Maybe I just have to Google this and a patch, as in you can just go to Kernel. What the fuck? Okay, yeah. You have this website, you can check this out. It's called kernelnewbies.org. Newbies. Something like that. I misspelled it. It's newbies.org. Yeah, it's just you'll be sending actual real patches to Linux kernel, and they do accept lots of Linux patches. You won't really, I mean, like, it's not like you, if you send patch, they won't accept it. If it's good enough, they will definitely accept it. Also, there's just too much code, so there's always room for everyone. There's at least, probably there's at least 500 or 5,000, 6,000 issues left right now. So you'll definitely have something to work on. First patch tutorial. Hmm. Yeah, it's just you have lots of code in Linux kernel and they need support. So you find a issue, you find the solution for it, and you send the patch, and you get your name registered in upstream, and you can actually showcase it in your CV. And also, most companies, they'll actually ask you whether you have upstream kernel experience, or have you landed enough upstream patches. Yeah, you can use this website. This website has everything about how you want to do this. And also you have now Claude and Gemini. You can actually easily find small examples or small patches, and you can try to explain, understand what's the issue and figure out the solution, and the actual rest of it, like formatting patch and other stuff, Cloud will handle it. Yeah, okay. You know, I need to understand. I have entry raw byte to pass this to either a directory or file entry. So, but in this case, it struct is has dynamic length. How can we cast it? Yeah, let's just see. Yeah, as I said, we have one length which is dynamic. So probably we cannot cast it, and it's true. Actually, this is what I guess the most recovery softwares would do. They would find recovery software. What it has to do is in a full scan is just take the entire physical thing, consider every block size. Let's say it starts with block size 4 KB. It takes every 4 KB block and it will try to parse it as a directory entry or a file entry and see what's inside that. And it just has to keep doing the same thing. That's why probably recovery softwares actually work, because recovery softwares can only recover stuff if the entire disk is not zeroed. Because as we know, if from high level, even if you delete some file, you are not really zeroing the block within the physical memory. The physical memory actually simply just probably removes the inode, so we know that that inode is free to use. So the actual physical block which previously had some data is there as it is. So a recovery software can actually go through every block, parse it as a directory entry or as a file entry, and see whichever parsing works and get into it and get the value. Probably it has something, probably it doesn't. In our case, we are doing the same, almost gonna do the same thing. So we just have to cast the current byte pointer, okay, to the struct and read the fixed fields. We should not read the dynamic fields. And once we have the name length, we can actually read past this field, I guess. That's how it was gonna work. So we're gonna just cast this struct from the beginning of that raw byte, and we're gonna only read these three fields. We're not gonna read this field because we still don't know the length. Once we have the length, which is the name length, then we can go to this offset and read until that, and then we will have to increment the current pointer past this field, past this length. Only then we can continue with the next directory entry. Yeah, that should be enough. Also, should I go with this or should I go with this? I think it's the same thing. It's just the offset is different. It doesn't matter. Okay, so let's write it. So we do have it already. So we have a inodes file type, and we have the static bytes of. Here we have assumed it as 128. I think it should be fine. So let's see. What we have to do is remove this. It's going to be a extend directory node, and here we know this is the raw byte starting address. And what is that raw bytes? Raw bytes is the entire block. Within that block, probably we might have more of them. So it's going to be extend directory node. Okay. I need to create another struct which is probably going to hold multiple extend directory entries. So it's going to hold extend directory nodes pointer. Yes. And the next value. Should I keep it as array or what? So we have the extend directory node, but probably a single block. When we parse it as directory, we might find multiple directories. So we need a struct to hold them as whole things. So we can have like directory entries. So if we call directory as entries, we'll get all the names. Something like that. We don't need to overcomplicate it and just keep it as directory node and do the parsing whenever we want to do it. No, it will be good to have a separate one, and it should have array of directories. So let's say directory node star entries dars, and let's make it static. We only going to have maximum of 128 directories. We're going to store just 128 directory pointers. Nothing much. Okay. So it's going to return the directory. Inside that we have dir. Wait, let's change it here first. It's going to return a directory. And it's going to have it something like this. 0 less than 128 I plus plus, and then we can have something like if directory current directory, so var I no, it should be dar dar I, and that is also a pointer. Within that we need to check file name equal to our etc, which is just a hard-coded thing, but we need to make that dynamic later. Let's just take these two and put it here and remove this. Okay, we're good to go. Now we have a proper loop. So initially we explore the tree and we get the results, and within the results we might have multiple counts. So we go through every count, we read the physical block, and we parse that as the directory entry, and we get a list of directories within that. So we go through every directory, but we should not go through every directory. Actually, we need to check if the directory actually has a value. Yeah, not we'll just be reading null pointers. I, yeah, we will. Let's just fill rest of it with zeros. That way we'll know equal to 0. In that case, I can just continue. If it's not, then I can get the I think I need to make this better. I need to write some parsing so that I can convert this into a list of different blocks, and then I can use that here. Okay, we'll do that later. Now let's just okay. So one more question is that here, how are we going to write the recursion? Because once we have the initial node, we go through all the entries. Now let's say we found this value. Now how are we going to pass it? How are we going to pass it again? Also, first of all, we need to get the, maybe it does have the inode value. Yeah, we have the inode number. So we have the inode number. We just will call explore again, and we would get a result. Maybe we can create some queue, and we just keep pushing, and in every iteration we'll just push all the block results there. Finally, we can do the entire think what's the right way to do it. I'm not sure. I have to think about it. Hmm. We have the first entry, we parse it, we get directories. Within every directory, we have a new inode. So now we have to go back and do the same steps again. So we should be able to do some sort of recursion here. But what is the output of the recursion and how are we going to use the results? So okay, let's say if I call this here, call explore tree recursive in this, I'll get a block results. Now I'm supposed to again, hi. Now I'm supposed to again call the same thing. I don't know, I guess I have to remove this entire thing into a helper. In that way I can actually call it in a recursive way. Is here, if we actually just do it like this, block result, second layer, explore trees, and here we have directories, and inode. So we have the number. So if I call it here, I would get a block results. And for that block result, I have to do this loop again. This loop. So I just have to maybe put this entire thing into a helper. If I do that, what will happen? I don't know. Oh, Rust is really good. But if you want to get things done, I would choose C. But Rust is really good. I use Rust a lot for maybe high level stuff, not for low level stuff. Rust is good because it has one thing which is a good package manager. But C also has a package manager. People just don't know about it. People assume that C does not have a package manager. Linux is the C's package manager. You can just install anything and you can include it. That was supposed to be the whole point of C, because C was developed, I don't know, but from my point of view, Rust has only one advantage, which is that cargo install. Other than that, I don't see any good things about it. But I write Rust a lot. You can check my repository. I write random shit in Rust. Also, people say that Rust got traction because of LLMs, because LLMs like a closed loop, so you can keep putting new program into your compiler and you get the errors and it can keep on doing whatever it can do. Not sure about that. Maybe it's true. But I write a lot of Rust. Almost every project I have dumped into my GitHub is written in Rust. When I actually worked on Rust back in 2021, I think so. I mean, at that time it felt good. This was the project I was helping with mostly. It's called Arkham. It's like a runtime authentication stuff. And I have contributed here a lot. Where is, how the fuck do I see if mine? Yeah, back in 2021 when there was this crypto and token stuff that was just going out of hand. At that time, everyone were trying out Rust, and I also tried Rust, and it was good. But I don't know. But right now, if you consider anything, I would still say C is better than Rust. But this is the only proper valid project I have contributed to in Rust. But I've written a lot of random stuff in my own Rust. You guys can try this out. This was a stupid thing. So it's like open storage. So anywhere in the internet, if you have a small space like a form or anything where you can store some bytes, you can consider that as a backend to store your actual stuff, and it will all be managed automatically. So I can have discard messages and uh, paste bin as backend, and I can store as much as I want. And the backends can be of anything, literally anything. As long as it has some API endpoint to store something, you can put that as a backend here. Yeah, I tried this and it's completely written in Rust. I guess it's unsafe Rust, not safe Rust. I don't remember. Let's see. Okay, it's safe Rust. Yes, it's safe. But I don't write safe Rust either. Probably this is LLM generated. Unsafe Rust is far better than safe Rust. You just write an unsafe Rust function and you wrap it with a safe, and you get the same amount of type check and you get the same amount of lifetime issues. So yeah. But overall, if you want to get something that is really valuable, then just use C. If you just want to have fun, Rust is better. Also, if you don't want any headaches of managing packages, then Rust is better. But I am a fan of Rust. I just don't like that because it does not get anything done. Somehow I'll end up writing something unsafe. I mean, it's not bad to write unsafe code. It's just that programming language keep saying that we need to write safe code to get things done. But when you actually try to get something done, you will end up writing unsafe Rust. And it's fine. So, but if I'm just gonna write unsafe Rust, then why the fuck did I even start here? I could have just wrote the entire thing in C, and I would have got the same performance and probably better value too. Because Rust is keep on changing. There's no like you cannot trust most of the packages. Almost every package is user developed, not some really tested code base. So yeah, so there's just limitations everywhere. But Rust is good. Good. Okay, so if I were to convert this into a recursive function, how would I do that? I've already removed this part into a separate helper. I guess I just have to remove this part into a separate helper. I think so. Let's try. Okay, I'm in inside box. Okay, you can just remove this and write something here. I don't know what the fuck is this. Voids recurs directory parsing. It's going to take some inputs which we can define later. We can paste the entire thing here and we can move this one step. What? What the fuck? Okay, it's moved. We need results. What the fuck is the results? It's a block. Results tab block the block results. So we get a block results. Oh fucking hell. I was talking about Rust and I'm writing Rust. Okay, so we have managed to move this out. So but what exactly is it gonna return? I don't know. It's going to return one layer of everything. So if we start from root node, it's going to go through every directory within it, and it's going to give us block result of that directory. Mm, yes, that is what it's gonna do. But what the fuck am I gonna do with that block results? That's not useful at all. What do I actually need? If I pass the root node, I need every directory within that root node. Every directory, as in, I just need the I just need the pass value. I don't need to go into that because I can do that again when I from a parent function. Yes, let's do it like that. Going to also take mm, no, it's going to go through every entry, parse it as directories, and now within every directory, okay, now I get it. I just need a results here and directory array. So it's like directory results. Okay, so now I can just push every directory result into that. And no, I don't fucking know. If I do that, what will happen? So I go to the first node, I pass it, I'll get multiple directories. I push that into that result. What now? I think that is it. Then in the parent function, I can just go through that entire list and see if anything actually matches Etsy. And then I can pass, if something matches, then I get the this, and then I call recursive directory parsing again. Maybe I think it should work. Let's try. You can remove this line. And remove this line. We also probably don't need this line. We are simply going to pass we also need a I value, so let's put event 64 I. No, current direct count. You can say directory results, directory count equal to DARS. Right. This. Directory extend I am trying to parse the extends entry within. No, I've already passed the extends entries. So I'm trying to write my extend for front end for my VFS layer. And in extend for we have extend entries, and every extend entry can be either a directory or a file. So currently I'm trying to write a recursive parser to handle that. Yeah, that is what is going on. Extend directory node, because every directory within is a directory node, not a directory. Okay. I keep using the same variable names and it's going to fucking mess me up sometime. What the fuck? Okay. Just here. Oh, how do you get to the point where you understand these and know how to do it? I mean, in general, I just use articles and you can also use LLMs. You keep asking questions until you understand what you want to write and you finally write that. But in general, first of all, you need to have a picture of how what you are about to write. In my case, I have a picture of what a file system is. File system is, in my case, is just f open. So in my kmain, I have this f open. So this is my high level picture. This is what I want to achieve. I know that if I call f open with a file path, I need to get a file struct out of it. This is the high level picture. Now then I went into it and started looking into what are the other things I needed. And then I figured out that I need an actual block layer first because there's multiple things. Block layer is the one that can actually interact with your physical file system. And you also need a virtual file system layer that is going to keep track of your block layer. So like, that was a big process. I was just going through that entire thing here. So yeah, this is how I imagined it initially. So I'm going to have something and I need a root node of this. And then I go through all the entries and I separate them into bin and ls. And once I have a inode, I can convert that into a file structure. And then I can go to my block layer and I can use block read and block write. And first of all, I just built my own picture of what I wanted to write. Probably most of it is wrong, but once you have the picture and you try to start implementing it, you will find that this is not going to work. And then you can fill in the gaps. And then you just keep iterating until you get an actual working version. But in most cases, because this is a kernel, almost everything is completely documented. So I don't really have to reinvent everything because if I just come here, it already shows exactly what I want to do. So I would say kernel is, at least because there's enough virtual file system layer will access block layer. Because kernel has enough documents out there, I can always just Google and figure out what I wanted to do. Maybe only if there's not enough sources out there, then it will be hard for me to come to a picture of what I want and then fill in the blanks, stuff like that. But right now, because it's kernel and it's completely documented, all I have to do is just come up with a simple example like what I want. In my case, it's just I want to call f open. And everything else was just I kept building images like this of how the flow will look like, and I kept implementing stuff because initially I started off with this file.h and my initial functions were, I guess, f open, f read, stuff like that. And then only after that I knew that I cannot simply write the file system layer first, that is the virtual file system layer first. I need a block layer, and then I finished the block layer. That took a lot of time. So block layer is over, and I'm currently supporting which IO block layer, and you can have multiple different physical block layers. In my case, I'm only supporting virtual which IO. For that too, I had a full specification here. If you go to my previous uh, thing, the previous exam streams, you would find it, because here this entire thing is already documented, which IO version 1.1. Almost everything is just about having a mental picture of what we want to achieve, and then you are just going to fill in the gaps based on external resources. And having LLM to ask questions always helps, but you should not believe whatever it says. Probably it's going to just say random stuff. How are we gonna read a physical block if we don't have a block layer? Because if you go to just let's say mm, do I have that SSH? Fuck me, it's not here. How do we start that? No. Okay, so in Linux, virtual file system layers only interact with inodes. There's no direct interaction with the physical layer, because if you say, you just say cat tests, you are not actually in, at least from virtual layer, you are not actually interacting with this file. You are just interacting with the inode, and this file has an inode. If that file existed, it will have an inode, and you are just interacting with that inode. If you open it, if you close it, if you remove it, you are directly interacting with the inode. And then within the virtual file system layer, you have front ends. Front ends are the actual, so virtual file system layer can have front end for a normal NTFS, or in my case, it's extend 4. So there's multiple uh, file system protocols. In my case, file system specification. In my case, it's extend 4, and I'm supporting extend 4 front end for my file system layer. And my extend 4 is actually going to internally use block layer. So if I come here, so take this as an example, it's just explore tree recursive. So I get an inode number. Let's say we want to read the inode, root inode, which is just this. So this is an directory, but it still has an inode. So we pass that inode here. We convert that inode into a inode struct. And because this is a extend 4 file system, every inode will have inode block, which is I block, which is just raw bytes. And this raw bytes can be parsed into extends. Every extent will actually have this is the extend header and extend leaf. If we parse that block, we'll get these entries, and within that entry you can actually get the physical block. So you have a inode number and you have a physical number. This is all you will get from the virtual file system layer. Now once you have the physical number, you can actually use your block layer to read it. So before I started my file system layer, I knew that after a little bit of digging, I figured that I actually need a block layer. So I wrote the block layer before that. So this is how the block layer is going to look. I need the virtuio, and I'm just going to, I have a test function. It's just block read the block number 1 and just print it. So I can use this same thing within my helpers. I'm just going, now that I know this inode is related to this physical block, I can just call block read with that physical number and I would get the outputs of it. So that's how this entire file system is going to interact. You have the high level helper, which is fopen. This is the whole point of this entire flow. And then I have the virtual file system layer, which is just going to keep track of inodes. And it's also going to have some front ends, which is in my case is extend4. And extend4 front end is going to interact with my block layer. And my block layer is going to interact with virch.io. And virch.io is the one that will actually make the physical read write calls. Because if you come here and yeah, my block reads, yeah, block read actually has sectors, and inside that sector I actually make this request, which is virch.io block in, which means read, and I just pass the sector number and I can get the value out of it. So there's multiple layers interacting with each other. Yeah, that's it. Overall, you just need a picture of it. Everything else you can actually build based on the resources that are found out there. You don't really need anything else. Everything else already exists out there. Also, now because we have LLMs, if you have a clear picture of what you want to write, you can easily prompt it and get what you want. But you should not believe it. You should always double check it. But that is true. But at least if you can get the picture of what you want to write, I mean, I get your point. My code is even cryptic for me because you might have seen, if you had seen my previous streams, every week I come back and I read my code and I'll feel like, what the fuck is this? So even I don't understand my code if I don't have enough context. So I have to go through all my code again and again in my stream to understand what I was trying to do. And I write comments there to see why I wrote that. So maybe from my streams, you can try to just understand the picture of what you want to write. And then you can build on everything on your own instead of relying on the code, because my code is probably a big mess. You can just, but probably my image or my picture of what I'm writing is same for you too, same for everyone, because I am following the same Linux structure. Yeah, so the takeaway can be just the image of every subsystem. So currently now I'm talking about file system, virtual file system. So I have explained you the flow. You can just take that flow into your mind and you can write down like an example like this. example like this. So how just with English words you can just say you will be calling this. Now what you wanna do and what's the next step and what's the final step. If you can write it in English of what you exactly want, then you can start filling in the gaps on your own. Probably writing the code is the easiest part. You just have to understand what you want to write. Maintaining is a different thing. That's my code is not maintainable. That's why it's not a real project. It's just a fun project. But this is just for learning purpose. This is the best way to probably learn things because you are not following on any steps. You are building your own mental model and you are building everything on top of it instead of following some tutorials or anything. Because if you're going to follow some tutorial, probably they assumed a lot of stuff they probably did not write in their article, and it will be like a mystery for you. Some of them would actually explain what are the assumptions they took. Even then, I believe this is the best way to learn. You just build your mental model and you write everything on your own. Yeah, this is how I have wrote everything. I always start with a small flow chart of what I want. In my case, I just want to read Etsy passwords. Let's see if we can actually manage it. I have read Flash. I'm almost there to read Etsy. Now I'm have to write some recursive function to do it as much as possible. Because user can pass as many as folders. I guess I don't know if my explanation was good enough, but yeah. Only thing you can take away from this is just you can if you can just get the mental image, that should be enough. Rest you probably can write on your own. Anybody can write it if they just put some efforts. Okay, where were we? We moved this and we created this new function. And here I have some yes, because this is the only advice I needed. I didn't get it from anyone. I just thought this is the best way to do it. Also, I got the same advice from TS Sodi. You can also watch his streams. He also does everything like this. But he won't. You can watch his streams. He literally does the same thing. He will start a project. He'll just read the documentation. He'll get an understanding of what it is, and he'll start writing the code on based on that. He'll never follow any tutorials. I like this guy. Also, he's a Emacs. So yeah, he's really fast. Okay. So it's extend directory pointer, and what am I assigning it? I am assigning a extend directory node. Okay. No, it's the same thing. Why the fuck it's not working? I want to store every directories that I have parsed. I'm parsing it, and within that I have an extend directory node pointer. Let's see. Extend directory node temp equal to, and now what are you, I can actually get the file name inode number out of it. So I can just say now I want to store all of these pointers in my results, but this is just one result. That's why it's not working. Will it work now? Directory result of directory count equal to temp. Okay, it fucking works. I, I start from the results. I go through every, I parse it once. I go through every entry. I update the result block with that 10. And then I just call recursive directory parsing with block results. No, I have to read the block result first. So it's going to be block results, and say second because it's the second layer. So here I can just call block read. I need to pass the sector. In my case, the sector would be temp, which is the current directory. Current directory dot. Where's my physical block? Maybe I should call this. Yeah, because I have a helper for that too. I just have to call. What is that? I call explore tree recursive with the inode number, which is the current directory. So we started off from root node. So now we are within every directory within that root node. So let's say we have etc. We go into that root node, which is temp, and the current file name probably is etc. So we just pass the inode of that. So now we have the block result of that new inode, and now we can recursively call that. So it's going to be second, which is the block results, and we need the directory results, which is the same. We just pass it down here again, and we need to increment the directory count. Directory count is equal to, and we pass that here. Hopefully my recursion is correct. So let's just write it down here. So we start from root nodes here. Let's say it has, we parse everything and we get the a block result for this. Now we go through every block result. So every result is probably just block results. We go through every block results. We get the physical block number. Get the physical block number. And what do? We get the physical block number, we read the physical block, and then we use that value to parse that as a directory entry. Okay, now we parse that block byte as directory entry. Okay. Now what do? So now actually we have the directories within the root node, which is slash. Probably example etc var bin etc. So we started off here, we got the block results, we get the physical block, we parse that as a directory entry. Now we have multiple directories, probably those are just etc var bin. Now we go through every directory entry that we just got, and we call it recursive. We go into them because we need to do it recursively, because we don't want to stop at the first layer. If it is etc, we also want to go into etc. So we call once we have a directory node, let's say this was etc, we get the inode of that etc and we call explore tree recursive, and we get a new block results. And now we can pass it again to our same function, which is recursive parse. And this would give us nothing because every output is just updated in this, and we also have the total count here. I think it should be good. Maybe finally we can return directory count. And it's going to be UN60. Yes, I think it should work. We have all the directories, we explore it, we increment it, and we explore it. Probably the exploration already found many directories, so we'll add it to our directory count. and then we return it. I don't know if this increment is correct. Maybe I have to run it and see if it's working. But at least it feels correct. Yeah, that is it. And we can just call to do. Let's put to do here. Call the recursive helper here. Initialize block results variables. Test this. Okay, guys, let's see tomorrow then. I guess it's enough for today. Tomorrow I'll just call this here and I'll actually try to run it and see if it's working or not, and then maybe fix the issues there. I think it should be good. Thank you, guys. I'll see you tomorrow then. Bye bye.